Determining correction factors for temperature involves a few key steps. Firstly, identify the ambient temperature. The ambient temperature is where the conductors will be installed. Secondly, calculate the correction factor. Locate table 310.16 in the National Electrical Code. This table provides correction factors for different ambient temperatures. If the ambient temperature is higher than the rated temperature of the conductor, the ampacity of the conductor must be reduced to prevent overheating. The correction factor would be less than 1.0, and the ampacity would be multiplied by this factor. If the ambient temperature is lower than the rated temperature of the conductor, the ampacity of the conductor can be increased to utilize the conductor's full current carrying capacity. The correction factor would be greater than 1.0, and the ampacity would be multiplied by this factor. For example, with an ambient temperature that is lower than the rated temperature of the conductors, the correction factor might be 1.5. This means that the ampacity of a conductor can be increased by 5%. Let's say a 250 mcm conductor is rated for 140 amps. To find the ampacity with the correction factor, multiply 140 amps by 1.5, which equals 147 amps. Therefore, the 250 mcm conductor could be rated for 147 amps at an ambient temperature lower than the rating of the conductor. The NEC, or National Electrical Code, provides tables for ampacity and correction factors based on conductor type and temperature ratings. These tables help ensure safe and reliable electrical installations by accounting for the effects of temperature on conductor performance. Using these tables correctly is crucial for preventing overheating and potential hazards. Always consult the latest edition of the NEC for the most up-to-date information and requirements. Remember that the specific ampacity ratings and correction factors can vary depending on the conductor material, insulation type, and installation conditions. So, it's important to refer directly to the NEC tables for accurate values. When applying temperature correction factors, consider the entire length of the conductor run. The ambient temperature can vary along the run, especially if the conductor passes through different environments. Use the highest ambient temperature encountered along the run to determine the appropriate correction factor. In some cases, you might need to apply both temperature correction factors and dirting factors for multiple conductors in a raceway or cable. Dirting factors account for the reduced heat dissipation capacity when multiple current-carrying conductors are grouped together. The NEC provides tables for dirting factors based on the number of conductors. When applying both temperature correction and dirting factors, multiply the ampacity by both factors to determine the allowable ampacity. Always perform these calculations carefully and accurately to ensure the safety and reliability of the electrical system. If you are unsure about any aspect of ampacity calculations or correction factors, consult with a qualified electrical engineer or inspector. Correct application of these factors is essential for compliance with the NEC and for maintaining a safe electrical installation. Understanding the principles behind temperature correction and dirting factors is also important. These factors are based on the thermal properties of conductors and insulation materials. Where a conductor carries current, it generates heat due to the resistance of the conductor material. The amount of heat generated is proportional to the square of the current and the resistance of the conductor. This heat must be dissipated to prevent a conductor from overheating. The rate at which heat can be dissipated depends on the ambient temperature and the thermal resistance of the surrounding materials, including the insulation and any surrounding air or other conductors. Higher ambient temperatures reduce the temperature difference between the conductor and its surroundings, which reduces the rate of heat dissipation. This is why the ampacity must be reduced at higher ambient temperatures. Similarly, grouping multiple conductors together reduces the ability of each conductor to dissipate heat, which is why dirting factors are applied. By understanding these principles, you can better appreciate the importance of applying temperature correction and dirting factors correctly. You can also make informed decisions about conductor selection and installation methods to ensure that the electrical system operates safely and reliably. Always remember to consult the NEC for the latest requirements and guidelines, and seek expert advice when needed. Accurately applying temperature correction factors ensures the longevity and safety of our electrical systems. By using NEC Table 310.16 and understanding ambient temperature influences, proper ampacity adjustments can be made. This proactive approach prevents conductor overheating, reduces the risk of insulation breakdown, and enhances the overall reliability of electrical installations. Moreover, compliant and well-maintained electrical systems minimize the potential for electrical fires and equipment failure, safeguarding property and ensuring the safety of individuals. It's essential to consider the specific conditions of each installation, including the type of conductors, insulation materials, and environmental factors. Regularly inspect electrical systems to identify any signs of overheating or degradation, and promptly address any issues to maintain optimal performance and safety. Education and training play a vital role in promoting safe electrical practices. Providing electricians and other professionals with comprehensive knowledge of temperature correction factors and other electrical codes enables them to make informed decisions and perform their work with confidence. Continuous learning and adherence to industry standards are crucial for staying up to date with the latest advancements and best practices in electrical safety. By prioritizing safety, compliance, and ongoing education, we can create a safer and more reliable electrical environment for everyone. Remember that electrical work should always be performed by qualified and licensed professionals who have the necessary expertise to handle complex systems and ensure adherence to all applicable codes and regulations. Taking shortcuts or neglecting safety precautions can have serious consequences, so it's essential to prioritize safety above all else. With a commitment to safety, education, and continuous improvement, we can create a safer and more efficient electrical future. Proper planning and design are also crucial aspects of electrical installations. Consider the long-term needs of the system and select conductors and equipment that are appropriately sized for the anticipated loads. Avoid overloading circuits or using undersized conductors, as this can lead to overheating and potential hazards. When designing electrical systems, take into account the environmental conditions and select materials that are suitable for the intended use. For example, in damp or corrosive environments, use conductors and equipment that are specifically designed to withstand those conditions. Also, ensure that all electrical connections are properly made and that all equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect against electric shock and equipment damage. Regularly inspect electrical systems for any signs of wear and tear, and promptly repair or replace any damaged components. Pay attention to any unusual noises, smells, or visual indications that may indicate a problem. By taking a proactive approach to maintenance, you can identify and address potential problems before they become serious hazards. Electrical safety is a shared responsibility, and everyone has a role to play in preventing accidents. Educate yourself and others about electrical hazards and safe practices. Follow all safety guidelines and precautions when working with electricity, and never hesitate to seek professional assistance when needed. By working together, we can create a safer electrical environment for ourselves and future generations. Always remember to disconnect power before working on any electrical equipment. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. And never work alone, so that someone can assist you in case of an emergency. When testing electrical circuits, use a properly rated multimeter or other testing device. Ensure that the testing device is in good working condition and that you are familiar with its operation, and always follow the manufacturer's instructions. When installing electrical wiring, use the correct size and type of conductor for the intended application. Follow all wiring codes and regulations, and ensure that all connections are properly made and that all conductors are properly insulated. When working with energized electrical equipment, maintain a safe working distance and use appropriate barriers to prevent accidental contact. Be aware of the potential for arc flash and other electrical hazards, and never take shortcuts or compromise safety in any way. Electrical safety is not just a matter of following rules and regulations. It is also a matter of developing a safety mindset and making safety a priority in everything you do. By cultivating a culture of safety, we can create a work environment where everyone is committed to preventing accidents and ensuring the well-being of themselves and others. So, let us all make a commitment to electrical safety and work together to create a safer and more reliable electrical future. These are the fundamental steps for determining correction factors for temperature. Be sure to consult the NEC for specific applications and situations. Remember safety first.